Hey everyone, so welcome to this deep learning playlist actually. So in this playlist on the first episode, we'll be talk about that single neuron. So in this video, we'll be discussing with what is neuron and how neuron will participate on deep learning things actually. So don't skip that video and let's learn that. All right. So the first thing, what is single neuron in deep learning? A single neuron transforms the given input to some output actually, depending on that given input and the weights assigned to that each input. Decide whether the neuron is fired or not like that actually. So let's assume that we have three neurons and each neuron have a simple example, just a three value ABC, and we'll apply some regression logic actually, and after that processing it we'll be get another output that called ABC. So this is how that neuron will work actually. And so create a fully connected neural network. So every neuron will have a fully connected with neural networks actually. And in that neural networks, so we can classify with the two ML problems, regression and the classification actually. And try neural nets with stochastic and gradient descent actually. So what is stochastic and gradient descent? So it's an optimization algorithm often used in machine learning application to find model parameters that correspond to the best fit between the predicted and the actual output actually. So that's why we use that this train the neural networks with. And we also do in that video so improve the performance with a dropout and a batch normalization and other techniques actually. So, hope this tutorial will introduce you to topics with the fully worked with the examples and then exercise. I'll be show some live examples and with apply with the real world data sets actually. So let's get started. So let's start with in deep learning. So that linear unit actually. So that fundamental component of neural network, that individual neuron, so I can show on diagram so you will get some understand actually. So I can draw that x, x and 1. So I have a two neurons. So one is to be calling to that another neuron actually. So this is weight actually, weight calling by w, this weight calling by b actually. And I have another neuron with the output of y actually. So that input of x, its connection to the neuron has a weight which is w actually. Whenever a value flows through the connection, you multiply the value by the connection weight actually. From the x, what reaches the neuron is w into x actually. So that x will reaches the neuron with using the w. So this is called w into x actually. So this, a neural network learns by modifying its weight actually. That's why. And the b is a special kind of weight that called as a bias actually. So they're called as a bias. So the bias doesn't have any input data associated with it. So instead we can put one and in the diagram. So that value that reaches that neuron just be since so we can put, so we can put 1 into b equal to b. Anyway, we will get the b only. So the bias enables the neuron to modify that output independently of its input actually. So you get it what I'm saying, right? And that finally the y value the neuron ultimately outputs actually. So to get the output, the neuron sum ups all the values it receives through the connection. This neuron activations like y is equal to w x w into that x actually, and plus b. So as a formula of already you know that. So w x plus b actually. So thus the y is equal to wx plus b looks familiar, right? Yeah. So it's an equation of a line, its slope of intercept equation, where w is equal to scope and b is equal to y, it's an intercept actually. So this is how that linear unit will it get work, and I'll show you some real-time example with that linear unit as a model actually. Through the individual neurons will usually only function as a part of larger network. It's often useful to start with a single neuron model as a baseline. A single neuron models or linear models actually. So let's think about how this might works on data set. So I have a data set like cereals actually. So this data set will have the all the nutrition data and 80 nutritional cereal products, and along with that that the that nutrition information actually. So let me show that. So this is the CSV, and so in that I have a 80 products along with that, so around 80. So in that each of the product how much have the calories, protein, fat, sodium, fiber, carbs, sugars, potassium, vitamins, salt, weight, and the carbs along with that rating. So I can keep that all the information in the serials.csv file. So this csv file, so in that mfr, right? So that mfr is manufacturer of a serial actually. So this is the I just mentioned that first letter actually. So this is called a manufacturer name, like a N for Nabisco, and P for Post, and G for General Mills, and Q for Quaker Oats, like that actually. So, but really think we need that calories and the protein, fat, sodium. So these are the things are that actually. So I just take this data set from Kaggle, and also I can take this data set and training with a model, sugars actually, training a model with sugars. So grams of sugars per serving as a input, and the calories per serving as a output actually. For example, if you serve that 1 teaspoon of sugar, so I need to get the result how much calories I can get based on my input actually. So we might find the bias uh, b equal to 90 and a weight is equal to 2.5. We could estimate that calories of the cereal with the 5 grams of sugar per serving like this actually. I'll show some diagram, so you will get some understand based on that actually. So I have a sugar, because in previously we have x, right? So in that I have a sugar, so I can wrote it sugar. So this sugar, and also in b level I don't have that still, so I can just keep it in the one. And weight, that mean that 2.5 weight actually. So that 2.5 actually. And also I can put that bias actually. So the bias b is equal to 90. So in that it will be calling that calories. We need to get that calories actually. And So as you get that sugar 2.5, so in that I can apply the real time examples. So that sugar of 5 grams of sugar, so 5 grams of sugar, and that same as bias, I can just keep it that. And so in that weight for 2.5, and the bias should be a 90 actually. And so I can make the process. So along with that I can get that calories actually. So that calories means multiply inputs by weights and the sum actually. So the results I can get that 102.5 actually. So this is how I can get. So let me show the calculation. And so the calories equal to 2.5 into 5 grams of sugar plus bias of 90 and result of 102.5 actually. So just like we expect actually. So this is how that linear unit as a model will it works for the single neuron actually. So the next thing will be look into that multiple inputs actually. So so that 80 cereals products dataset has many more features just sugars actually. So what if we wanted to expand our model, include things like fiber or protein content that easy enough, right? So we can just add that more input connection to the neuron and one for each additional features to find the output. We would multiply each input to its connection weight and then add them all together actually. So let me show same as. So I can draw. First I can draw with x of 0 and x of 1, x of 2, and a bias. Oops. Yeah. So here it is. So in that I have a neuron. So in that neuron I have a multiple inputs actually. So I can just simply pass through that and let me connect. So that all the things will connect with the neurons and that neuron will return that y actually. So the x of 0 I can call it as 0 w0 and a w1 and a w2 and of bias actually, as you already know, right? So this is how will it works. And that formula, we the formula for this neuron would be so y is equal to first weight of 0 along with that x of 0 plus at the same time weight of 1 along with that x of 1 and also weight of 2 and x of 2 plus you expected, right? So you already predicted, so b bias. So the linear unit with the two inputs will fit a plane and a unit with the more inputs than that fit a hyperplane actually. So if n number of inputs if we have, the neuron will automatically take care of that based on that formula actually. So this is how that that in-depth neuron level will it works. That next thing, that important thing, this how linear units we implemented in Python using Keras model actually. So let me show that what is Keras and why it's used actually. So Keras is the high level API of the TensorFlow platform, and approachable, highly productive interface for solving machine learning problems with a focus on a modern deep learning things actually. So that's why we can always prefer that Keras. So it's also a high level API of the TensorFlow platform. So uh, TensorFlow and Keras both are almost same, but there is a high level APIs will be we can use in the Keras, like predefined models also will be there in that Keras level actually. And coming to the linear units in Keras, the easiest way to create a model in Keras through the class of Keras.sequential actually. So in that, so I can show that. Hold on, Keras dot sequential. So which creates a neural network as a stack of layers, and we can create a models like those above the dense layer actually. So which that dense layer, those are things will come on the next video in the same playlist, and you can find it through there. And so in that linear units in Keras level, we could define a linear model accepting three inputs features actually. So one is for sugar, sugar, and fiber, and protein. Oops, protein actually. So and producing that single output called as a calories actually. So as you already know that it will be all the things will it go to the neuron, single neuron. So along with that, it will be generating that y, that's called calories. So calories actually it will be generate. So in the code level, we can we can create a code in TensorFlow and Keras. So we can type as in the code level, and let me open the code from TensorFlow, and in the TensorFlow we have a high level API Keras, and from TensorFlow dot Keras, and in that Keras I can import that layers actually. So you got it right. So that next thing, we can create a network with one linear unit actually. So in that one linear unit level, let me type the code. You can easy to understand that. So model, we need a model, right? So model equal to Keras dot. As I already said that, so we can use that sequential. Oops, typo. Yeah. So in that. I can put an array. So in that array, layers, and in that dense of units equal to 1. At the same time, we need three. We have a three inputs, right? So in that, you can easy to put input shape equal to 3 actually. So that you can put it easily. So this is how we need to create a network with a one linear unit actually. So with that first argument, as you can see in the code actually, so let me expand it so you could get better understand over there. When the first argument units, we define how many inputs we want actually. So in that case, we are just predicting that calories will be using that units 1. With the second arguments, input shape, we'll tell the Keras to dimension of the input, setting input shape, ensure the model will accept three feature as a input like sugar, fiber, and a protein. So this is model is now ready to fit to training data actually. So the next part we'll see on the next video, and keep please subscribe my channel for that next video in the playlist. And thanks for watching, and love you all. Cheers. Bye. What is Keras? And we hope you found this video informative and helpful. If you did, please hit the like button and consider to subscribe our channel for more videos like this in the future. Also, don't forget to share this video with your friends and colleagues who might find it useful. If you have any questions or comments, please leave them in the comment section below, and we'll be happy to respond. Thank you for watching. We'll see you on the next video.